Hey everyone, in this video I just want to give a brief demonstration and talk about NAT, public and private IP addresses. This concept is brought up quite a bit in the VPC chapter here of the AWS Cloud Curriculum. And we've talked about this before in the networking classes, but maybe you need just a quick refresher. So that's what this video is for. Let me just draw up a quick, simple network here. Let's pretend we have the internet represented by the cloud. That comes into our home, into, let's say, a cable modem, which then plugs into a router, which could be a wireless router. Routers typically have the arrows on it here. And then off of the router, our PCs are connected. And so if they're wireless PCs, we have our connection wirelessly. If they're hardwired PCs, we have our connection through the wire. Now we know in order to be on the internet, we must have a public IP address. And unfortunately with IPv4, they have essentially run out of public IP addresses. So what they did was they developed something called NAT, Network Address Translation. And what that simply does for us is it gives us some private IP addresses that any network can freely use. So anybody can create a network with 192.168 for the first two octets. Anybody can create a network that starts with 10. And then the last one is anything that starts with 172.16 through 172.31. So like a 172.20 would be considered a private IP address. So those are our private IP address ranges. Sorry, my writing isn't all that legible. I'm writing with my finger on a touch screen, so it is what it is. But let me highlight this concept of a private IP address. Most of you, if you're at home and you looked at the IP address of your computer, you would probably see a 192 address. So if I do that on my computer here, and I do an IP config, helps if I spell right. I need to look at my wireless adapter because that's what I'm connected to on the internet. I have a 192.168 address, 192.168.1.44. The subnet mask is a 222.550, which means these first three octets are for the network and cannot change. The last octet, which matches up with the 0, means this is reserved for the host portion, and this will change from computer to computer. The default gateway, that's my router. That's how I get outside of my network. I send traffic to that default gateway. But if you looked at your IP address at home, you probably have a 192.168 address as well, or potentially. And we know that to be out on the internet, you must have a unique public IP address. Because let's pretend, for example, that this computer over here wants to go out to the internet, wants to go out to Google, so it sends the request to the router up to the internet looking for Google. Well, if Google needs to respond back to this PC that had an IP address of 192.168.1. Let's just say 44 like I showed, there are probably thousands or maybe millions of computers in the world that have that same exact address. How does Google know whether to deliver it to my PC at my house or somebody else's PC over in China or your PC in your house? Because chances are that that IP address is not unique. Well, that's where NAT comes in. NAT basically allows us to share one public IP address. So how this works, basically how this works is we are given one public IP address to essentially share. And so our modem is where that address shows up. So on the modem, you are given some sort of public IP address. And I'm just going to make this up, 54.23.6.12. Now, why is that public? It's a public IP address because it's not part of any of those private ranges that I mentioned. It's not a 192.168. It's not a 172.16 through 172.31. and it's not a 10 address. So any other address besides those 3 special ranges are public IP address, and a public IP address can never be used twice. So I will never ever see another 54.23.6.12 assigned to any other cable modem or to any other networking device or anything. That's going to be unique and cannot be reused. So what happens then is when that same PC that has an IP address, and let me just throw it in here, of 192.168.1.44. When he wants to communicate to the internet, let me throw a few other addresses in here. Let's say our default gateway or our router has that. And let's say this PC over here is 192.168.1.2. So what happens now when this PC over here wants to communicate out with the internet, he sends his traffic to the router. And what the router does is says, oh wait, you are a private IP address. You cannot go out on the internet. So instead, what we're going to do is we're going to use something called NAT. We are going to keep track that the internal PC of 192.168.1.44 is going to Google. We're going to let you borrow this one unique public IP address to go out to Google and to do your Google search. Then when Google responds back, Google is going to respond back to this one public IP address. This one public IP address is unique. No one else uses it, so it's definitely going to get delivered back to my network. When the return traffic comes in, the router looks at its NAT table and it says, oh, who requested the Google search on boats? It was the computer at 192.168.1.44. So then it can go through the NAT sort of in reverse and get the traffic back to the PC. The way that the NAT table looks is it actually has something in there known as the source and destination port. So inside of the NAT table, I would see something like 192.168.1.44 and the automatically generated port that it used to get out to the internet, and the mapping, which would be Google's IP address, and I don't know what it is. I suppose I could look it up. Do that here real quick. $142,250, 7246. 142,250, 7246. And that port is probably port 443, web traffic. And so now when Google responds back, Google is going to then have a source port of 443 with a destination port of 1060. So that combination of the port and private IP address, port and public IP address, is kind of how NAT keeps track of all the different conversation. Because this PC over here could also have a search at the same time going out to Google, and through NAT, it's also going to borrow this one public IP address. But what makes that traffic unique? Well, a couple different things. The source port that was used from this PC, which is dynamically generated. In this example, it was port 1060. Maybe over here it's port 5040. And so the NAT tables keep track of that. And it also has a different IP address of 192.168.1.2. But the internet doesn't care about that. The internet just worries about this public IP address. Can I get the traffic back to this public IP address? And then the router, which is doing all of the NATing for us, keeps track of which conversation goes where. So there can be hundreds or thousands of PCs sharing one public IP address. And that one public IP address is being shared, and that NAT process, the NAT table, keeps track of all the different conversations being used along that one public IP address. If you are gamers out there, you've probably seen your different type of NATing, like you have strict NAT or you have an open NAT, or that all has to do with the visibility of your PC out on the internet or your gaming console out on the internet. Is this exposed to the internet? Kind of in a way, but not directly, because it has to go through NAT, and that public IP address has to be shared. I can get into that with another video if you are interested in how that works. So I saw that my laptop here has the IP address of 192.168.1.44, but that's not what I use to get out on the internet. So if I do a quick search here, if I do a quick search here of what is my IP address, it actually shows that my public IP address is 163.123.6.99. And all of the PCs that I have on my network would share this IP address to get out to the internet. And I have, several between TVs and laptops and cell phones and whatnot that access the internet, all using this one public IP address. And then it's my router. Well, I actually have a firewall. It's my firewall/router that keeps track of all those NATed conversations. So again, hopefully that gives you a little bit of insight into private IP addresses. Remember, we have the private IP addresses that can be used for any internal network that anybody can freely use. We have to have unique public IP addresses to go out onto the internet. The problem is we don't have a whole lot of those public IP addresses available to us. They've essentially run out. So what they did was they developed NAT so that we can use those private IP address ranges out on the internet by borrowing or NATing that one public IP address. Now keep in mind, IPv6 is different. You can NAT with IPv6, but you don't need to, because there are enough public or unique, what are called global unicast addresses available, where I can have direct end-to-end connectivity on the internet and not have to go through any NATing or network address translation. If you have any further questions after watching this, please let me know. If I've confused you even further, I apologize, but hopefully that gives you a little insight into how the private IP address ranges are working. Thanks for watching.